So 5.3, we're going to be solving trig equations. So we're continuing with our trig and we're bringing back the unit circle. When we're solving trig equations, we always want to get our variable by itself. So we want to isolate the variable. So for example 1, what do you think I should do first? Add 1 to the other side. Then I have 2 sine of x is equal to 1. What do you think I should do next? Divide by 2. Awesome. We want to get our trig function with that variable all by itself. So I have sine of x is equal to 1/2. Now in terms of x and y, sine tells us to look at which one? The y. So we're looking at y values with our sine. So sine tells us we have to look at the y values. So we need to see where on our unit circle is our y value 1/2. So we're going to go to our unit circle. We need to look and see where our y is 1/2. So where would that be? Pi over 6 because y is 1/2 and 5 pi over 6 because y is 1/2. So my answer here would be x is equal to pi over 6 and 5 pi over 6. All right. Sometimes we may have 2 trig functions. We want to collect like terms, so we want to combine them to be one. What would you do first here? I can add the sine to the other side. So move that to the other side. So that gives me, what's sine plus sine? 2 sine. So 2 sine of x plus square root 2 is equal to 0. Now we want our trig function all by itself. So what would I have to do next? Subtract square root 2.
Wait, why did you add,
Because I wanted to combine my like terms. So if 2 sine is equal to negative square root 2. Again, we want our trig function all by itself. So what would I have to do? Divide by 2. So it'll cancel out with that 2. So I have sine of x is equal to negative square root 2 over 2. Once our trig function's all by itself, we want to look at the unit circle. So sine tells us to look at what values? The y values. So we need to see where our y values on the unit circle are negative square root 2 over 2. So where would that be? Perfect. Our y value is negative square root 2 over 2 at 5 pi over 4 and negative square root 2 at 7 pi over 4. So our 2 answers would be x is equal to 5 pi over 4 and 7 pi over 4. All right, example 3. We're doing the same thing. We want to get our trig function all by itself. So what would we do first? Add 1. So I have 3. Tangent squared is equal to 1. What would I do next? Divide by 3. So tangent squared is equal to 1/3. What should I do next? Square root both sides. Perfect, because I want to get rid of that squared because my tangent isn't by itself yet. So I need to square root both sides and it'll cancel out that squared. So I have tangent of x is equal to what? Yes, but what am I missing? Plus or minus. Anytime we take the square root of both sides, you need that plus or minus. Why is it square root 3 over 3? What did we do? We had to rationalize. So it would be like, this would be 1 over square root 3. We multiply the top and the bottom by square root 3. So we get square root 3 over 3. So this and this are the same. This one is just rationalized.
was there a square root over the 1? You just made it 1?
Yeah, what's the square root of 1? 1. So now tangent tells us to look at what values on our unit circle? Y over x values. Now, y over x isn't given to us on the unit circle, but we could figure out what they are. So I'm going to look at my first quadrant here. Once I figure out the y over x in this quadrant, it'll tell me what the rest of them are too. So y over x for my first pi over 6 would be 1/2 over square root 3 over 2. Keep, change, flip. So what would we get here? We're looking, since it's tangent, that tells us we have to look at y over x values. So I just put my y over x. So the y over x.
But like, how did you know that it was that one? Like, why is it?
I'm doing it for all three of these.
Oh, okay.
So we have to do it for all three. Once we know these three, the other three in each quadrant are going to be the same, just depending on which one, and I'll show you how we can pick. So when we simplify this, we get 1 over square root 3, which is square root 3 over 3, which is what we're looking for. So we know that pi over 6 is going to be our answer, but let's just figure out what the other ones are too. So for the second one, for pi over 4, I have y over x, so that would be square root 2 over 2 over square root 2 over 2, which would simplify to what? 1. And then let's do the third one up here too. So y over x would be square root 3 over 2 over 1/2. Keep, change, flip. So this would be square root 3. Now the other quadrants, the three terms there, will match these depending on what your denominators are. So I know that pi, since this is pi over 6 and it gave me what I was looking for, that square root 3 over 3, this one's going to be the same because it's 5 pi over 6. This one's going to be the same because it's 7 pi over 6 and 11 pi over 6. So all the ones that have the denominator of 6, those are going to be our answer. If I simplified this to y over x, it would come out to negative square root 3 over 3. So this one down here would be a negative divided by a negative, so this would be positive square root 3 over 3. And then the one in the fourth quadrant would be negative square root 3 over 3. But since I'm looking for the plus or minus square root 3 over 3, it's going to be all 4 answers. So you just have to be careful with the signs. The ones with the same denominator will always match up, but just be careful with the signs. If you have a negative divided by a negative, it turns positive. But here is just an example where I'm looking for the positive and the negatives. So it's all 4 of them. Just because it's the first quadrant, so they're all positive, and then the rest of them follow the same pattern. So as long as you know these three, the rest of them will match up. So like, if I was looking for where tangent was 1, it would be pi over 4, and then all the ones that have the denominator of 4 will also be 1, but the sign may be different, depending on which quadrant it's in. So as long as you know the ones in the first quadrant, the rest of them will match that same pattern. That's what I was looking for, was where tangent was square root 3 over 3. So what would my answers be? Perfect. So it's all 4 of them. Mm-hmm. Right, because in the other ones I was only looking for like where it was positive 1/2. So I was just looking for the positive ones, and there's only 2 of those. All right, example 4. So here I have different trig functions. It kind of gives me a hint in the directions that I'm going to have to factor. So whenever I factor, I need it to be equal to 0. So I'm going to move that 2 cotangent to the other side, subtract it to the other side. So I have cotangent times cosine squared minus 2 cotangent is equal to 0. What should I do next? Awesome. They both have a cotangent in common, So I can take out that cotangent. So I'm dividing that cotangent out, and I'm left with cosine squared minus 2. So we divided out that cotangent, factored out the cotangent. Now I can just set each piece equal to 0. So I would say cotangent of x is equal to 0. And cosine squared minus 2 is equal to 0. I'm going to treat each one separately. I'm going to find out where cotangent of x is 0, and then I'll do the cosine one after that. So cotangent tells me I have to look at what values? X over y values. So I have to do the same thing I did before with the tangent ones, but instead of y over x, it's x over y. So on my unit circle in the first quadrant, I need to figure out what x over y is, but what am I looking for? 0. So which points do you think I'm going to have to look at on my unit circle? I need to look at 0, 90, 180, and 270 because those are going to be the ones that give me 0. So I need to figure out where x over y is 0. So let's do it for 0. Because it's not going to be any one of these, because these will give me something like square root 3, 1 over square root 3, and 1. So it's not going to be 0. So we have to look at the 0, 90, 180, 270. So let's do it for 0. X over y would be 1 over 0. Is this 0? What is this? Undefined. Let's do it for pi over 2 up top. So x over y would be 0 over 1. What would this be? 0. So this is one of our answers. Let's do it for pi on the left. So negative 1 over 0, what would this be? Undefined, so it's not that one. And then 3 pi over 2 on the bottom. X over y would be 0 over negative 1, which is 0. So what would my two answers be? Pi over 2 and 3 pi over 2. So x is equal to pi over 2 and 3 pi over 2. Now we're going to do the same thing with the cosine one. Is the cosine one solved all the way yet? No. What would I have to do next? Add 2. We need to get that trig function all by itself. So I'm going to add 2 to both sides. So cosine squared is equal to 2. What would I do next? Square root both sides. So cosine of x is equal to what? Plus or minus square root 2. Now cosine tells us we have to look at what values? X values. So on our unit circle, we need to see where our x values are either positive or negative square root 2. So let's look at our unit circle. Do we have anywhere where our x values are positive or negative square root 2? No. So this one doesn't have any solutions, so we would just stop there, and our answer would only be these two.
Wait, how did you know that? Oh, because there was nothing.
Yeah, let's look at our unit circle. We're looking at the x values. So our x values, none of them are just square root 2. So we don't have any answer there. So this one technically would be no solution, but I don't want to write no solution because the question isn't no solution. We still had 2 answers here. So these are our 2 answers. All right, let's look at example 5. Anytime you have a trig function squared and a trig function that's not squared, we're going to have to factor. So this is kind of in the form as 2x squared minus x minus 1. If it helps you, write it as this and factor it that way, and then just replace your signs back into the x's. How would I factor this? I want to multiply the first times the last. So that gives me -2. What are two factors of -2 that add to -1? -2 and +1. So this would be sine -2 and sine +1. What do I have to do next if I start by multiplying? Divide. So anytime we start by multiplying, we have to go back in and divide. So simplify if we can. This first one will end up being sine -1. What happens if we can't divide? Put it in front. So this would be 2 sine +1. What am I going to do next to solve? Set them both equal to 0. So sine of x minus 1 is equal to 0. And 2 sine x plus 1 is equal to 0. And then we just solve them both individually. For the first one, what would I do? Add 1. So sine of x is equal to 1. I'm going to go ahead and solve the second one too, and then we can look for our values on the unit circle. So for the second one, what would I have to do? Subtract 1. So 2 sine is equal to -1. And then divide both sides by 2. So sine is equal to -1/2. Sine tells me I have to look at what values on the unit circle. Y values. So I need to see where my y value is 1. So going to my unit circle, where is my y value? 1. Pi over 2. My y value is 1. Is that the only place? Yes. So this would be x is equal to pi over 2. And then we have to do the same thing for the other one. Again, it's sine, so I'm looking at my y values. So where is my y value? -1/2 on the unit circle. 7 pi over 6 and 11 pi over 6. Awesome. So here, I would have x is equal to 7 pi over 6 and 11 pi over 6. So these would be my 3 answers. Example 6. What do you think I would need to do to solve? So I have a squared trig function and a not squared one. Can I factor it? Why can I not factor it? Because they're not the same trig function. They're different. So do you think I could make them the same trig function? How? I can change the sine squared. I know that I have my identity sine squared plus cosine squared is equal to 1. So if I was going to replace the sine squared, I would know that sine squared is equal to 1 minus cosine squared. So I'm going to replace this sine squared with 1 minus cosine squared. What would I need to do next? Distribute the 2. So 2 minus 2 cosine squared plus 3 cosine minus 3 is equal to 0. What's next? Combine 2 and -3. So that would be -2 cosine squared plus 3 cosine minus 1, because I combined my like terms there, is equal to 0. What can we do next? I can multiply the first and the last, but what would I want to do to make this a little bit better for us? I'm going to divide everything by -1 just to change the leading coefficient, because we don't like it when it's negative. It just makes our life a little bit harder. So I'm going to divide everything by -1, flip all the signs. So this is now 2 cosine squared minus 3 cosine plus 1 is equal to 0. Bless you. Now what can I do? Multiply the first times the last. We're going to factor it. So I get 2. Do I have two factors of 2 that add to -3? -2 and -1. So this would be cosine minus 2 times cosine minus 1. What do I have to do next? Divide both of them by 2. Do not forget to divide. So I get cosine minus 1 and 2 cosine minus 1. Now I can set them both equal to 0. So I get cosine is equal to what? 1. And the other one, I need to add 1 to both sides and then divide by 2. So cosine is equal to 1/2. What's next? Awesome. Cosine tells us we have to look at the x values. So I need to see where my x value is 1. So I go to my unit circle. Where is my x value 1? 0. Anywhere else? Nope, that's it. So x is equal to 0. Now we need to do the same thing with the other one. I'm looking for x values again. So I need to see where my x value is 1/2. So go to my unit circle. Where is my x value 1/2? Pi over 3. Anywhere else? 5 pi over 3. Perfect. So my answer would be pi over 3 and 5 pi over 3. So these would be my 3 answers here.